welcome back, my seventh grader. Let's go ahead and knock out this homework. I got all the odd ones, so I'll start with number one. It says find the sum or difference. That means I'm going to go ahead and combine these. I'm going to take 5b minus 9. I'm going to combine it, since I'm adding here, with the like terms. I'm just going to stack them, b plus 8. Well, this is going to give me negative 9 plus 8, which is negative 1. I know that because when my signs are different, I find the difference, which means I'll take the big number minus the small number, which is 9 minus 8. That gives me 1, and then I'll keep the sign of the bigger number, negative. And I have 5 plus, or 5b plus b, that would be 6b. So the answer to this will be 6b minus 1. All right, number 3 is next. But I think what I'm going to do number 4, because number 3 is just like number 1. It's an addition problem. I'll show you how to do the subtraction problem over here. On this one, we have 7g minus 6. We're subtracting 3n, negative 3n, excuse me, minus 4. All right, so to do this part here, I have to remember that it's negative sign in front changes everything inside this parentheses. So this is now going to equal 7g minus 6, and a negative times a negative is a positive. So this is like adding 3g, a positive 3n, excuse me, and with a negative times a negative, a positive 4. Now this is designed to be a tricky one, to make you not notice that the n and the g are not even the same variable. I can't combine them. So in reality, I can't even stack them this way. I'd have to stack it this way. I have to add, I'll take the positive 4g, but now I'm going to move that positive 3n over here. Whoops, sorry. So this would be positive 3n. Okay. And now this is like adding 0 over here and adding 0 over here. This would be 3n. Negative 6 and 4 is negative 2. And 7g plus 0 is 7g. All right, now you know how to do ones like number 4. All right, next, got to evaluate the expression. I'm going to do number 5. This is a negative 6 to the second power, which means negative 6 times 6. Notice the negative sign does not go in front of each of these. If I wanted that power of 2 to affect the negative, I'd have a parentheses around both the negative and the number. 6 times 6 is 36, so this is negative 36. Number 7 is next. I got a negative times a negative times a negative. Well, that's definitely going to give me a negative answer. Now, I've got 7 times 2 times 4. I know 7 or 2 times 4 is 8. 8 times 7 is 56. So this should be a negative 56. All right, next is number 9. Copy and complete the statement using less than, greater than, or equal to. All right. Well, I know that the absolute value of 3.5 is 3.5. And I know the absolute value of negative 5.8 is 5.8. And I know that 5.8 is bigger than 3.5. So this one is less than. Now it seems like it's a good time for a code word to see who's uh, watching the videos and not or not. And the code word for this particular homework assignment will be, let's see, spicy trail mix. All right, so that's going to be our code word for this homework. And if you put this on your homework and turn it in, you'll get a treat from me for watching the video. Now I'm going to go ahead and erase the video or erase the code word so people that are just fast forwarding don't see it, only the people that really watched it. And I'm going to go on to our next thing, number 11. Number 11 says, write two different expressions that represent the area of the shaded region. Show that the expressions are equivalent. So two different expressions. Okay, I can say that, let's see, remember it has to represent the area, right? The area is going to be length times width. So my length can be 6.5. And my width could be 3x. And it says of the shaded region. So this is the shaded region here. This could be 3x plus 4 minus x plus 2. 3x plus 4 and then we're going to put minus let's see here. And we'd have to do all this first, so I'll have to put a bracket here. Minus x plus 2. Another way you could write this, I could put 6.5 times 3x plus 4 Sorry, my mouse is giving me a little issue here. And I think I'm just going to type this out because it's really turning out kind of messy. I'm not really liking that. I want you to see it nice and neat. So this could be 6.5 times 3x, sorry, 3x plus 4. I could put minus 6.5 times x plus 2. And there's even a third way you could write it if you wanted to. You could solve this part here, which would give you 3x minus x is 2x, right? So I could put 6.5 times 2x, and then 4, remember this is going to be a negative 2, so 4 minus 2 would be 2. So we could put plus 2, all right? And I believe that would work as well, all right? Now it says show that the expressions are equivalent. All right, well, let's go ahead and do this over here. The first one, remember I have to do parentheses first. So I'm going to take my 3x plus 4 minus my x plus 2. And when I do that, that's going to give me 3x plus 4. Let's see, that's going to turn to plus A negative times a positive is a negative. So this would be a negative x. And this would be a negative 2. All right, now I can move this down here. Negative x minus 2. And that's going to give us 5 or 6.5 times 2 plus 2. I'm sorry, that should be 2x. 2x. Let me erase that. As you can see, that's exactly what we have over here. If I was to do this one, let's see what happens when I solve this. This will give me 6.5 times 2. That'll give me a 13x plus 13. All right, now if I was to solve this one, this would be 6.5 times 3x plus 4. I'd be minusing 6.5 times x plus 2. All right. 6.5 6.5 times 3x. Let's get our calculator for that. So that'd be 6.5 times 3 will give me 19.5 x, and then 6.5 times 4 will give me 26. All right, and that would give me, over here I'd have to multiply this number to everything inside of here. So this would be a negative 6.5x minus 13. All right, now I can combine my like terms and put my x's together. So I'm going to take this negative 6.5 this negative 18. This is going to give me, let's see, 8. Okay. Make sure I'm doing this right. Oh, I'm sorry. This was a 2 up here, wasn't it? And that's a 13. So this is not 18 at all. That should be 13. I apologize. It's always good to double check what you're doing and make sure you're doing it correctly. And 26 minus 13 is 13. And 19.5 minus 16.5 is 13x. And as you can see, we have the same answer. All right, the same value for both. All right, and we already know that this one equals this because that's the same as that right there. All right, let's go ahead and do number 13. Simplify the expression, it says. Well, this is where I distribute properties. 3 times a is 3a. 3 times negative 7 is negative 21. Next, number 15, we do the same thing. Distribute properties. Negative 9 times negative 5 is 45, because a negative times a negative is a positive. 9 times 5 is 45. And then a negative times a negative is also positive. This is 4, well, we can say cats if we want to. Right, so negative 9 times negative 4 cats, we'll just put negative c. 9 times 4, that's going to be 36. Since there's a c, we put a c afterwards. Negative times negative is a positive, so that answer is correct. Number 17. We're going to distribute properties here, and here, and here. But I can combine like terms first. See the d's? So I'm going to do that first to simplify this. This would be negative 6 times negative 4d and positive 3d make a negative d minus 8.3. All right. Now I'm going to take, yeah, 8.3, yeah. All right, and now I'm going to take 6 multiplied to negative d. A negative times a negative is a positive, so this would be 6d. Negative times, negative 6 times negative 8.3, that's also going to be positive. Now I just have to find out what is 6.3 or 8.3 times 6. 498. And since this has a decimal place, it's more likely going to be, should be 49.8. Next to number 19, this time we're taking a fraction, multiplying it across. This isn't that hard really because I remember this is like over 1. Now with a 4 and 8 there, I can say 4 divided by 4 is 1, 8 divided by 4 is 2. Now I have a negative times a negative is a positive, so this would be a positive 3 over 2, y. All right, and yeah, because this is going to give me a 1, 3 times 1 is 3, 2 times 1 is 2. And then we have to multiply this to z, so this would be a negative times a positive makes a negative, and this would be 3 over 8 z, yes, z. All right. And I realized I can't take 3 over 2 and simplify it. I could just make that 1 and 1/2. And I do like teaching you guys how to simplify correctly, so we're going to change 3 over 2 to 1 and 1/2. So our answer should be 1 and 1/2 y minus 3 over 8z. Let's go to this next one here. Okay, I'm multiplying these together and these together. I can't reduce, so this is going to be 20 over 9a plus let's see, this is like 9 over 1, so this would be 3, this would be 3 here, so when I reduce it, it's going to look more like, well, 3 is going to come, yeah, if 3 is going to come over here, because 9 divided by 3 is 3, 3 divided by 3 would be 1, so this would be 15b plus 15b. Now I'm going to go ahead and, you know what, let me make sure that was like a b, so nobody gets that wrong. And now I'm going to take, let's see here, I'm going to erase this so it's evident it's a 3. But we still have to multiply it to this last one, right? And so this would be 5 times 2 is 10. 3 times 3 is 9. And this is also an A. Well, I could have saved me some work by adding these two, and I probably should have. In fact, that's what I'm going to do. I don't want to teach you the wrong way. I didn't notice that there were two A's here. So we should combine like terms in the parentheses first. And 4 over 3a plus 2 over 3a is going to equal 6 over 3a. So let's rewrite this to show 5 over 3. We're multiplying that to 6 over 3a plus 9b. Okay. Now I can reduce this because 3 divided by 3 is 1 and 6 divided by 3 is 2. That's going to give me 5 times 2 is 10 and 3 times 1 is 3. This would be 10 over 3a plus, now we could put this as 9 over 1. And once again, since this is a 3, I'm just going to erase this to put that 3 again. Uh-oh, I don't know, error there. There we go. Oh, wow, sorry about that. All right, something funny is happening over here that's really not that funny. So I'm just going to leave that there. We know this is a 3. We can reduce it by 3 again to make 1, and 9 divided by 3, oh my. 9 divided by 3 will be 3. All right, so now we got 5 times 3, which is 15. So this would be 15b. All right, and we can reduce 10 over 3. This will become 3 and 1/3 a. Plus 15b. All right. Number 23 is next. It says that, well, okay, I can go ahead and multiply first here. This would be 4c plus 3c to the second power. We're going to subtract 0.75c. That's 0.75 times c is 0.75c. And then plus 3, so we have to multiply 0.75 times 3. Well, 0.75 times 3, that's 2.25. So, let's see. Yeah, that was multiplied to 3, so that's going to be minus 2.25. All right, make sure of that. Yeah. Now I can combine like terms, okay? I cannot combine the 3c squared because there's not another 3c squared, so I'm going to put that in front here, 3c to the second power. I can combine 4c and negative 0.75c. That will give me a 3.25c. And then we can go ahead and we could have actually put this c to to the first, oh, that we did, first power. And now minus 2.25. All right, and that's it. Next is time to go to number 25. Your friend simplifies expression. Is he correct? Explain your reasoning. Well, he said that negative 2 times h is negative 2h, and negative 2 times 8k is going to be 16k. Well, we forgot that a negative times a positive will make this a negative. So, no, your friend is not right. He only applied the negative to the first term in the, shrink this here a little, second, or let's see, in the parentheses. He only applied the negative to the first term in the parentheses. Okay? That's why he's wrong. Number 27 says, determine whether the expressions are equivalent. So are these expressions equivalent? Okay. So we have this term and this term. Well, this is going to be 2 times 7x, which is 14x. This is 2 times negative 5, which would be a negative 10. And then we're going to add 8, it says, plus 8. Well, I know negative 10 plus 8 is negative 2. So this is 14x minus 2. And let me make sure that we got this right here. 2 times 7x is 14x. 2 times negative 5 is negative 10. And then we add 8. Negative 10 and 8 make negative 2. And, yep, this is not the same expression. So, no, not the same expression. All right, let's go to number 29. This time we've got to multiply 3 over 2 times g, which makes 3 over 2g. And now we're going to have to multiply to negative 3 over 4. Well, you can't cross multiply any of this. So this would be 3 times negative 3, which is negative 9, 2 times 4, which is 8. So we're having plus, and then we're going to have, well, I guess it's really a negative, isn't it? All right, there we go. And this is going to be a negative, and this would be 9 over 8. And plus 2, okay? And then there's the comma there. I have a number here that I can combine with this. Remember, this is really negative 1 1/8, right? So this is 3 over 2g, which is really 1 1/2. Let's rewrite that as well. 1 1/2 g. And now we have negative 1 1/8. We're going to add it to 2. Well, I know 1 1/8 times, or plus 2 is going to give me a positive 7 over 8. So this would be 1 and 1/2 G. Oops, sorry, my mouse is really giving me problems today. And we're going to be adding 7 over 8. All right, I'm just going to clean up that 2. It's really ugly. There we go. All right, now we got to solve the other one over here. And we don't have any distributive property. We do have 2 minus 5 over 8. So let's see what that's going to be. 2 minus, is that 5 or 9? I want to say that's 5. And 2 minus 5 over 8 is going to give me 1, a negative 1. And if that's 5 over 8, where's that 9 over 8? I really trying to look at this the right way, but I think it's 9 over 8 now. Because 5 is over here. It doesn't look like that one. So I'm going to go at 9 over 8. So I'm going to have to change my answer there. Because 9 over 8, we said right over here, was 1 and 1/8. That's a negative 1 and 8 and a positive 2. Those are the same numbers. So this is also going to equal 7 over 8. And now we have 3 over 2g, which again we said was 1 1/2 g. So let's see. This was a positive 2, so this is going to be a positive because it's a bigger number. And yes, they are the same. So we could put yes for this one. And I don't know if we, oh, this one we said no. All right. All right, we're going on to number 31. The cost in dollars of a custom-made sweatshirt is represented by 3.5 N plus 29.99, where N is the number of different colors in a design, okay? Write and interpret a simplified expression that represents the cost of 15 sweatshirts. Okay, it says N is the number of different colors in a design. Write and interpret a simplified expression that represents the cost of 15 sweatshirts. Okay? The cost in dollars of a custom-made sweatshirt is represented by this. That's one sweatshirt. They want to know what 15 is. So I think we're going to be using distributive. That's exactly what we're doing here. This would be our answer. And the way they got it, it's just as I said, they took 15, they put it in front because there's 15, they multiplied it the cost of 1, which is 52.5 N plus, let's see, 229.99. Okay, so remember, the cost in dollars of a custom-made sweatshirt is represented by this here. So if we were doing this, I would say N is the number of different colors in design. We're taking this and multiplying it to this, and then multiplying it to this. So watch what happens when I do that. I'm going to take my 15, multiply it to 52.5. As you can see, that's going to give me 700 and make sure this 15 times 52.5, 787 0.5 times N. I'm having to start to reevaluate myself. Oh my gosh. Okay. That was my mistake. This should not be 52. It should have been 3.5 n. All right, so let's rewrite that. And I apologize, I wrote the wrong number. It should have been 3.5. Okay. Now let's take 15 and multiply it to 3.5. And that gives me my 52.5n. And now we're going to take 15 and multiply it to 22.99. And I want to make sure, 29.99. And that gives me the 449.85. That's how they got this. And that's for 15 shirts. It's costing $52.50 for each color, because that's $52.50 right there. And then $449.85. All right, let's go to the next one. Number 33. I've got predict whether the instructions below will produce equivalent expressions, then show whether your prediction is correct. All right, so I got subtract 3 from n, that's n minus 3. Add 3, okay, n minus 3. We're going to add 3 to the result, and then triple that expression, okay? So this whole expression here, we're going to multiply to 3. Okay, so I know that if I do the inside part first, and I have to, this is going to be n minus 3, and then plus 3. I'm not multiplying these together here. I'm just adding it. So that's going to give me, well, negative 3 and plus 3 make n. So this is 3n. And that's pretty much it, because the 3 minus 3 took away from it. All right, the next one says subtract 3 from n. So again, I will take n minus 3. There's a triple the result, so I will multiply this times 3. And then add 3 to that expression. So I'll add 3 at the end. So 3n, 3 times n would be 3n. 3 times negative 3 would be negative 9. Negative 9 plus 3 is going to give me negative 6. And 3n minus 6 is not the same as 3n. So let's see, predict whether the instructor will produce equivalent. No, they will not. No, they will not produce equivalent expressions. All right, let's go to number 35. So draw a diagram that shows how the expression can represent the area of a figure, then simplify. Okay, draw a diagram to show how the expression can represent the area of a figure. That's easy. If I was to take, let's just make it a nice, neat shape, shall we? We'll take a square here. And I could say that this is 4 plus 1, and this is x plus 2x. So this times this will give me this. All right, number 37 is next. Looks like the last one. A square fire pit with a side length of s. Okay, this is the square fire pit has a side length of s. So this is s, and that means up here is also s. Oh, good, they got it down here. I didn't need to write that. Oops. Now it says is bordered by a 1-foot square. So right here is a 1-foot square all the way around, right? So how many stones does it take to border the fire pit with 2 rows of stones? So we got 2 rows here. All right, wow, that's a lot of stones. So remember, this is S feet. So if this is S feet and it says this is a 1-foot square, that means from here to here is S. It also means from here to here is also S, right? So if I'm going to do this, it says, let's see, to take to border. So we're talking the perimeter here. So we already know this is going to be S and then another S, right? S, so 2 S's, right? And then we're going to add, let's see, I got 2 S's. I really need to make that more legible because it looks like a 25. So I'm going to put 2S, and then we're adding, right? We're adding the S to this. Let me see how I would do this. I think a better way to do it would be, let's see, I've got S plus 1 for 1 square foot. So I don't know why I put this as S. I should have said this is 1. I apologize for that. If that's 1, this is 1, this is 1, this is 1, this is 1, right? This is 1, this is 1, and this is 1. So the way I'm seeing it, we're going to be taking S plus 2, right? So let's try that. S plus 2, because that's one way across. And we're adding it to 2 more S's, right? 2S. Actually, this is 2 S's plus 4 then. What? No, because it's going to be twice, so I take that back. 2 S's plus S, right? And we multiply that to 2. Well, that's S and S, so that would be 2 S's plus, let's see, this is S, this is S, this is S, this is S. We could say 4 S's altogether, okay? So 4 S's, and then plus, we're going to add 1, 2, 3, 4 to this, okay? Let's see here. 1-foot square tiles, okay. Now we're going to have to do the same thing over to this one. So let's add. We have the same thing, plus we have, this is S, but we're adding 2 this time each side, right? So that's going to be 4 us again. And then we're adding, instead of 4, 1, 2, 3, 4, we're going to have, let's see, well, that was 4 S's to here, so we're going to be having 2 by 2, that's 4 on each corner. So that's going to be 4 times 4, that's going to be 16. And I'm thinking, without checking for the answer, of course, this is going to give me 8S. And then I'll add my numbers plus 20. Let me make sure I do that right. I'm glad I checked because I have to realize now that this was not going to be 16 like I thought it was, because I counted all 4 of these and then added these 4. So really that was another, that's another 3 on each side. That would have been 12, not 16. Or I could have just said that, make it even simpler. This is going to be 1, 2, 3, 4 each. So we could take this 4 off completely because that's included in there. So that's going to be equaling 16. Now it says you border the fire pit with n rows of stones. Oh wow. Okay. How many stones are in the nth row? Okay, you border the fire pit with n rows of stones. How many stones are in the nth row? And this last one here, I'm just going to paste your answer here. Oops. And I'll let you know I'm not really interested in anyone getting B right. It was really complicated. As best I can describe it, they're saying this is the answer here. They're saying row 1 is 4 S's. Well, that makes sense because this is 1, 2, 3, 4 S's plus 4. That's 1, 2, 3, 4. That was row 1. Row 2 is 4 S plus 2's. And if you think about it, this is S, and then we're adding 2 to each side. So 4S plus 2, right? You can S plus 2 and multiplying it to itself 4 times. And then adding 4. That's going to equal 4S plus 12. Because we'll have 4S plus 8, and 8 plus 4 is 12. So they're saying, so that row n is going to be 4 times S minus 2, n minus 1, plus 4. So n minus 1 is taking the or being added into this, because we're taking away one of the, let's see, the rows, right? All right. Well, that's it. We'll grade it in class and have a good one.